In this video I'm going to be looking at the solution of question 2 from the January 2010 Edexcel FP1 paper. The topic of the question is numerical solutions of equations. In the question we're given a function f of x equal to 3x squared minus 11 over x squared, and first of all simply asked to calculate to 3 decimal places the values at 1.3 and 1.4. We're then told that the equation has a root, or f of x equal to 0 has a root alpha between 1.3 and 1.4. And starting with that interval, asked to use the interval bisection method to find an interval of width 0.025. So we've got an interval there of width 0.1, so we're going to have to use interval bisection twice to get to a width of 0.025. In the final part of the question, we're asked to start with the first approximation at 1.4 and use NewtonRaphson procedure only once to obtain a second approximation. Well, the first part is just one of calculating values, so f of 1.3 is simply substituting 1.3 into the given function, and that comes out to be negative 1.439. F of 1.4 is equal to 0.26. Actually it's 267755, but the 3 decimal places 0.268. Well, in this particular question we've been told there is a root between 1.3 and 1.4. Often, however, you would be asked to prove that, and that would come from the fact that the values that you've just found, one of them is negative and the other one is positive, so that change of sign implies there's a root in the interval between the two values 1.3 and 1.4. However, here we're just asked to use the interval bisection method, so the next point to check is the midpoint, those at 1.35, and substituting those values, or that value rather, gives us a value of negative 0.568. And because that one is negative and f of 1.4 is positive, that means there is a root in the interval between 1.35 and 1.4. So taking the midpoint of that interval at 1.375 and calculating again, we find that again this is a negative value, negative 0.466. So therefore the root is in the interval between 1.375 and 1.4. So we've achieved the aim of getting an interval of size 0.025. The marking for those two parts of the question, well, this was simply a B1 mark, so no method required in part A of the question, just B1 for getting those two values correct. There was then a method mark and an A mark for the first use of the interval bisection, and then finally another A mark there to give the 3 marks for that part of the question. In the final part of the question we're asked to use NewtonRaphson procedure. So to do that we need to first of all differentiate to find f dashed x, and that is 6x and then plus 22 over x cubed. So that was by writing this or thinking about it as being minus 11x to the power minus 2. So when we differentiate, multiply by the negative 2 to give the plus 22 and reduce the power to negative 3, in other words 22 over x cubed. x1 were, the first value x0 we probably refer to it as is 0.4, so x1 is then using the NewtonRaphson equation that's in your tables is the value x0 1.4 and then minus f of 1.4 divided by f dashed of 1.4, and that is 1.4 minus, I'm going to use a value which is greater than the 3 decimal places. We're asked to give our answer to 3 decimal places, so I'm going to use a value which is has more significance, so 26775 for f of 1.4, and f dashed of 1.4 is 16.4175, and that's equal to 1.38369, or to 3 decimal places 1.384. Now I think in this particular case there's the answer comes out if you use 3 decimal place values here in this first part, this part of the question here. You still get 1.384, but do be careful about using numbers which are not sufficiently accurate enough when you're doing this. The marking for that was a method mark and an answer mark, accuracy mark for doing the differentiation. A method mark for using NewtonRaphson equation and correctly evaluating at this point, and then a final answer mark. It's given in the mark scheme as correct answer only. In other words, there would not be any follow-through marks at all available on that particular question. So there's the total of the 5 marks in that part of the question. That completes this question. There are other questions and other modules available at www.furthermaths.org.uk.